15 years after he published his special theory of relativity, and 5 years after he published his general theory of relativity, Albert Einstein stood before an audience at the University of Leiden. He spoke in German, but in English, one of the things he said was, "According to the general theory of relativity, space without ether is unthinkable. For in such space there not only would be no propagation of light, but also no possibility of existence for standards of space and time." The man who is most often credited with killing the ether said it was unthinkable to do without one. That fact has been quietly omitted from the standard history of physics. The concept of the ether has a long history. Aristotle proposed a fifth element, one that filled the heavens and admitted no void anywhere in the universe. René Descartes revived the idea in a mechanistic form, proposing it as the medium through which forces propagate. Isaac Newton, though known for treating light as a stream of particles, proposed that those particles moved through a subtle ether whose vibrations explained the effects his particles alone could not. Christian Huygens used it to explain the wave nature of light. Benjamin Franklin proposed a similar subtle fluid to explain electricity itself in letters to his friend Peter Collinson. James Clerk Maxwell built his entire theory of electromagnetism on the assumption that light was a wave in something. William Thomson proposed that atoms themselves were vortices in the ether. Hendrik Lorentz mathematically refined the concept of motion through the ether. Albert Einstein categorically stated that there had to be an ether for the properties of light to exist. These were not fringe thinkers. Aristotle stands among the greatest minds Western civilization has produced, and the rest were leading figures in the development of modern physics. In 1887, Albert Michelson and Edward Morley's experiment failed to detect the motion of the Earth through that ether. In 1905, Einstein's special theory of relativity showed that the speed of light was constant for any frame of reference, regardless of any ether. And this was interpreted by subsequent physicists as meaning that an ether wasn't necessary. What replaced it was something remarkable: the assumption that light needs no physical medium, that waves can wave in nothing. The theory of wave physics is going to put that assumption to rest. Of course, a wave is a disturbance in some medium. In 1801, Thomas Young performed one of the most important experiments in the history of science. He shone light through a hole in a window shutter and split the light with a thin card. What he expected to appear were two bright lines, but that's not what he saw. It was a pattern of alternating light and dark bands, an interference pattern. That pattern requires crests and troughs. Where a crest meets a crest, you get brightness. Where a crest meets a trough, they cancel, and you get darkness. The mathematics is unambiguous, and the experiment has been reproduced countless times. Only waves make such an interference pattern. Light makes that interference pattern. Therefore, light is a wave. A crest and a trough are physical displacements. Waves on water are displacements of water. Sound waves in air are displacements of air. A wave is by definition a displacement of something. If light is a wave, and Young's experiment proved that it is, then light is a displacement of something. That something is its medium. That medium is what was called the ether. The Michelson-Morley experiment didn't prove there was no ether. It proved that the ether doesn't drag against moving bodies the way the 19th century model assumed it would. That's a constraint on what kind of ether exists, not evidence that it doesn't exist at all. And the ether wind was actually there. Scientists at that time had been seeing it for decades without knowing what it was. It is still seen in laboratories around the world today without knowing that that's what they are seeing. Wave physics takes the ether seriously again. Not the mechanical jelly of the Victorian imagination, nor a substance that drags against the earth as it moves. Something simpler and more fundamental. The next video will examine that medium in detail.